তো সবসময় যখন ঢুকবি, ধর ক্লাসরুমে ঢুকবি, তখন প্রফেসরদের গ্রিট করবি, ঠিক আছে?
ওকে
না, আমাকে গ্রিট করতে বলছি না, আমি বলছি আর কি, গ্রিট দ্য
ওকে
প্রফেসর।
ওকে।
হ্যাঁ। আর তুই একবার দেখে নে তোর ওই এক্সেল শিটে তোর নাম আর ঠিকঠাক আপডেট করা আছে না কিনা।
এক সেকেন্ড। না, এখনো আপডেট করিনি আমি। আচ্ছা, হ্যাঁ, হয়ে গেছে হয়ে গেছে।
আমি করে রেখেছি, ছেড়ে দিয়েছি, নামটা ঠিক আছে তো?
হ্যাঁ 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 হ্যাঁ, ঠিক আছে।
ওকে। আচ্ছা, এবার তুই বেরিয়ে আসতে পারিস ওখান থেকে, কারণ তোর ভিডিও দেখা
হ্যাঁ।
যাবে না বেরিয়ে।
ও
ওকে
আচ্ছা
ফাইন।
আচ্ছা।
ওকে, এক সেকেন্ড। ওকে। তো তোর লাইক ইউজুয়ালি টিচারদের কাছে কিন্তু তোদের খাতাগুলো থাকবে, ঠিক আছে? তো ওরা
ওকে
কিন্তু জিজ্ঞেস করতে পারে তোর মানে খাতা দেখে জিজ্ঞেস, যদি কোনো ভুল করে থাকিস সেটা নিয়ে কিন্তু জিজ্ঞেস করতে পারে তোর, মানে পিএসবি বা পিএসএ, এটা যাই হোক না কেন, ঠিক আছে? যদি কোনো ভুল করে
ওকে
থাকিস পার্সোনালি আর কি।
ওকে
আহ,
ওকে
সেটা কিন্তু আমি জানি না, তো আমি জিজ্ঞেস করতে পারছি না, এবার আমি এমনি জাস্ট আস্ক করতে পারি, ঠিক আছে?
ওকে।
তো এই
ঠিক আছে।
পিএসবির যে এই 4 নম্বর প্রবলেমটা, যে ইউএনভি, আর আমি স্ক্রিনটা শেয়ার করছি।
হ্যাঁ হ্যাঁ, ওই বাইনোমিয়াল ডিস্ট্রিবিউশন ফলো করে যে প্রবলেমটা।
হ্যাঁ, যে
রুটস অফ
ইউএনভি
দ্য
আর
ইকুয়েশন।
হ্যাঁ, ইউএনভি। সো আমি ইংলিশে কথা বলা উচিত, ওকে, লেটস নট টক ইন
ওকে।
বেঙ্গলি। সো লেটস সে
ইয়া ইয়া।
ইউএন so let's talk about this fourth problem. UNV are independent identically distributed random variables. They follow binomial parameters n comma half, and t is the random variable, you know, the number of distinct real roots. So how
Hmm.
did you solve this problem?
Yeah, regarding this problem, here we have the random variable t denotes the number of distinct real roots of the quadratic equation.
Mm-hmm.
Okay. In this case, t follows uh, binomial. We know that in case of a quadratic equation, the maximum number of real roots can be 2 and the minimum can be 0.
Okay.
So I did it in this approach that t follows binomial 2 comma p, where p is the probability that a root of the given equation is real.
Binomial
So
2 comma p.
yes,
It can be 0.
0
Sorry,
1 2.
0 1 2. So binomial, how is it happening binomial?
A binomial in the sense that it satisfies all the criterion of a binomial distribution.
But binomial distributions take two values, or 0 and 1. So it's not a binomial
No,
distribution.
no, no. I think you're talking about Bernoulli distribution.
Oh, I'm so sorry. Yes, you're right. Yeah. So, yeah, you're right. So binomial distribution follows this. Okay, but binomial distribution should be sum of Bernoulli. So you cannot say if a random variable can take 0 1 2 value, it's always binomial, right?
Yes, yes. But then on seeing the question, I thought that it follows all the criterion of a binomial distribution. That is the, if we consider it in a binomial distribution setup, the trials are independent.
So you have to prove that T follows binomial. So how do you prove that?
Uh,
So if you think binomial, I don't know like whether it's a binomial or not.
okay.
Think about it.
Yeah. Uh, Suppose I define another random variable,
Mm-hmm.
say x. where x is a Bernoulli random variable. It can take 1 or 0. It is 1 if a given root is real and 0 if it is complex. So if I
Uh,
express it in
one
that way,
one
1
if
is
it's real and zero if it's complex. Okay, it's a Bernoulli. Okay.
yes. And here, since uh, here t is basically sum of all those xi's which are real.
Okay, but the indicator random variable that the roots are real,
Hmm.
that is the Bernoulli, right? They are not like they are not IID, right? So how will you add it up? Even if it's not IID, they are not like, maybe you can say like sum of two Bernoulli can give to binomial, because binomial n comma p and m comma p is that. But how do you? It's not independent either. So how do you do that? So why binomial? Like, I mean, that's the question.
Uh, I thought it would be binomial because it seemed that it follows the criterion of a binomial distribution.
Okay. Okay. So let me give you some hint. Okay. So
Okay, okay.
what if you just take a normal, like, it's a discrete distribution, it's not a continuous distribution either. So, and it
Yes,
can take 0, 1, 2 value. So what if you can just try to make it into try to find the corresponding PMF of this distribution.
yes, I can deal it in that way that suppose I can set up the PMF in that way that I can write some t in the beginning which
Please
can
do
take
it.
the
Please
value.
do it in your copy and tell me the
Yeah,
answer.
yeah. Suppose t takes the value 0, 1, 2, and probability capital T equal to small t. For the first, that is, suppose the if I set up the PMF, probability t equal to 0, that is, the equation has no real root. In that case, if I write the discriminant, it will be b square minus 4ac less than 0.
Okay.
Then if I write it in that form, then I'll get finally u square probability u square less than v square.
This is for.
This is for t equal to 0.
Okay.
So corresponding probability will be probability u square less than v square, where u follows binomial n comma half and v follows binomial n comma half, and they are u and v are independent of each other.
So T is equal to 0 is equal to probability u square less than equal to v square.
Just u square less than v square, since zero real roots, so it has to be both the roots have to be yes, both the roots have to be complex. Wait, wait.
Think about it. Take your time. Take your time. Don't hurry.
Hmm. Yes. Probability t equal to 0 is that it means that both the roots have to be complex. So it will be whole square of this probability. That is, one root is complex and the other root is complex as well. So it will be probability of u square
So
less
can you
than v
tell me,
square.
like, so what is the probability T is equal to 0? What is the probability T is equal to 1? What is the probability T is equal to 2?
Yes, probability t equal to 0 is the whole square of the probability u square less than v square. And I have to compute this thing, this probability u square less than v square.
Okay. And equal to 0 is
This
u
is
square
for
less than
equal to 0.
equal to 1.
And for equal to 1, it means that one root is real, the other is complex. So here
Wait,
will be,
for equal to 1 means
there is this. Okay, number of distinct real roots. Just one distinct.
Okay, take
Okay,
your time.
suppose uh, if t is 0 here, it means that it has no distinct real roots. There can also arise the situation that all the roots are real but equal.
Yes.
So they are not distinct, but they still satisfy. Okay, then more cases will come under it.
Yeah, please do it.
Yeah. Yes. So under t equal to 0, there will be two cases. We have to add the two cases. First case is both the roots are complex. For that, the probability is probability u square less than v square whole square of this. And
Okay.
along with that, another situation is that both the roots are real, but they are not distinct. They are equal to each other.
Okay, then.
So in that case, the determinant discriminant is equal to 0.
Okay,
So,
so
so u square equal to v square. That is
so what will the probability t is equal to 0?
sum of both of these. That is probability of uh, so that is basically probability of u square less than equal to v square.
Good. And what is the probability t is equal to 1?
Yes. For that, it means that the given quadratic equation has one distinct real root, and since it has one distinct real root, the other root has to be complex because it can't be a real root again, because in that case there will be, if it is distinct, then there will be two distinct roots. Also, if it is suppose I have a root x1, suppose the two roots are x1 and x2, and x1 is real and x2 is also real. In that case, if x1 not equal to x2, then also this situation won't be satisfied. So in this case, one root has to be real, the other has to be complex. So
Okay,
for
so what
that,
is the probability of that?
the probability will be that probability of u square less than v square multiplied by u square greater than equal to v square. This
Okay, and yeah,
this should be the probability.
okay, and what is the probability of the other thing?
Yeah.
Probability equal
For
to.
yeah for equal to 2, it means that both the roots are distinct. So in this case, it should be probability of u square greater than v square whole square of this. The discriminant is just greater than 0, not greater than equal to 0, because there is no situation of equal roots here. Both the roots have to be distinct.
So you got the three probabilities. Please add it up. So what are you getting?
The computation is coming out to be a bit rigorous.
The sum of the probabilities coming out greater than 1.
Actually, I'm getting difficult to break the probabilities.
Okay, so tell me about this thing.
Mhm.
Probability t is equal to 1. Like, do you think t is equal to 1 is a possibility?
One distinct real. There is one real.
So what do you mean when we say one distinct real root?
Okay, it's not possible. Not possible. There cannot be one distinct real root. It has to be either 0 or 2.
Why?
Because there's a contradiction here. If I try to bring in a situation of one distinct real root, then, like, for example, I consider two roots x1 and x2. One distinct real root will mean x1, say x1 is that one distinct real root. It means x one distinct real root. What if x1 is a real root and x2 is complex?
Yeah,
Then also it will be one distinct real root, right?
so can there be a for a quadratic equation, can there be a one real root and one complex root?
Oh no, no, complex roots always have to be in pairs. There cannot be one complex root.
So you have the answer.
Yes, yes. Just two situations are possible.
Great. So you have got the probabilities. Right now
Hmm.
you can easily find the expectation and variance, right?
Yes, yes. Got it.
Right. So you
Hmm.
are right in the sense that it was a binomial kind of framework, 0 and 2. It's like twice, like this distribution by 2 is a binomial, okay?
Yes, yes,
T by 2 is binomial. Sorry, Bernoulli P. T by 2 is Bernoulli P, okay?
yes, yes,
So T by 2 is Bernoulli P, but a P is the probability of that U squared is greater than V squared.
yes.
So how do you find this probability U squared than V squared?
Probability u square greater than v square. U and v individually follow binomial n comma half, and they are independent of each other. So u square greater than v square means
Did you do this problem in the exam hall?
I did this, but I think I did this wrongly because I considered it as a binomial setup and I did it.
Okay.
Uh, u square greater than v square can be broken up in probability of u greater than v, because u and v always take positive values. So there will be just one case probability of u greater than v, and then I have to take case wise. Like since they're independent of each other, I can take case wise and break it up.
So yeah, tell me.
U minus v greater than plus one. Yeah, I've thought of an approach here. Probability of u greater than v is probability of u minus v greater than 0,
Okay.
and I can write it as u plus n minus v greater than n. That is, I've added n on both the sides.
U plus.
n minus v. It is u minus v greater than 0. I have added an n on both the sides. That is,
Okay.
it is finally u plus n minus v greater than v. It's greater than n. Sorry.
U minus.
U minus v greater than 0 it was. I added an n on both the sides of
Okay, I
the.
understand. So U square is greater than V square is the condition. So
Yes, yes.
is U square minus V square greater than 0, you told, right?
But u square greater than v square can be then written as probability of mod u greater than mod v.
Yeah.
But if I further then break it up, u and v always take positive values. So there'll be just one case that is probability of u greater than v.
Okay.
So then I brought v to the other side, that is u minus v greater than 0, and I
So
added
U
an n on.
square.
Huh.
Okay. Okay. So you get, see, U square minus V square is greater than 0 means U minus V into U plus V is greater than 0, right? And U and V are, U plus V is always greater than 0 unless U and V are 0.
Yes,
So how do you manage this situation? You understand there is an issue.
that is u minus v u plus v greater than 0.
U and V can be 0, right? Both. So how do you manage that?
Actually, actually, I thought that probability of u square greater than v square, if I just take square root on both sides, it will be probability of mod u greater than mod v.
Yeah.
So since u and v always take positive values, so it should be the mod u should be the same as mod u in general. I think.
Yeah, you got U is greater than V. Then what?
Yes. Yeah. Then I write u minus v greater than 0.
Okay.
Then I add an n on both the
But
sides.
remember
Mhm.
that even if, okay, U minus V is greater than 0. Okay, please go ahead. Yeah.
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 Then I add an n on both the sides such that I write it as u plus n minus v greater than n.
Okay.
Now u follows binomial n comma half. V follows binomial n comma half as well.
Okay.
And we know the property that v is of success. V is a success. Is it is dealing with number of successes. So
Mhm.
n minus v naturally will deal with the number of failures.
Okay.
So n minus v by the property should follow binomial n comma half.
Okay.
So I basically then n minus v is also follows binomial n comma half. U follows binomial n comma half. So by the and they're independent of each other. So by the reproductive property, I can say that u plus n minus v together follow binomial twice n comma half.
Okay.
So so I have, if I take it as a variable z, then it just boils down to probability of z greater than n, where z follows binomial 2n comma half, and then I write it as in the summation form. I can write it this probability.
Okay. Okay. That sounds good. That sounds good. That sounds good. So let's say U and V, like, can be any distribution, right? So how will you solve this equation in that case?
Sorry. uh, uh, you're saying if it is any other distribution other than binomial.
Yes.
Uh, if it is a known distribution, and if u minus v again follows a distribution, then I can do it that way. But if it is say some distribution where u minus v is the distribution of u minus v is not known to us, in that case I'll have to take case wise. Like when here, then I have to take just u greater than v, which means that whatever is the value of v, I'll have to subsequently multiply the probability of the value of u's which are greater than that of v's. For example, if v is some value 0, then you will take the values 1, 2, say till n. Then I'll add probability of v equal to 1, then you can take the value 2, 3 till n.
Okay.
So in that way I can proceed.
But what if it's a continuous distribution?
Oh, if it is continuous, then I can take it can be a case of double integral where uh, since it is u and v are independent, so finding their joint PDF won't be an issue.
Mm-hmm.
So I'll write probability of u greater than v, and then in the the integral which is inside, which is of u, will be v to say, wait, u greater than v, v to infinity. That is the range of u,
Okay.
and then the outside integral will be the range of v, whatever range is given to us, to say
Mm-hmm.
minus infinity to infinity.
Mm-hmm.
And the the function inside will be the joint PDF of u and v. That is in this case just the product of their individual PDFs.
Okay. So now let's say uh, u follows normal theta comma 1 and v follows normal theta comma 1.
Hmm.
And you know that the roots of this equation.
Yes.
Okay.
Hmm.
The corresponding pair of roots for each of this, like you take the realization of that. Okay. But you have lost the u and v values, but you know the roots. You
Okay.
understand? So u and v follows normal theta comma 1, both of them independently.
Okay.
And instead of knowing u and v, you know the roots of those equations. Imagine from the u and v's, 10 data points are collected. U1, V1, U2, V2, U2, V3, U10, V10. Okay.
Okay. Okay.
Now taking, instead of knowing the U and V, you have the roots. For U and V1, you have root R1, R2. For U3, U2, V2, you have to root R2, R3. Like R1, R2, nahi, let's say R1, S1, R2, S2, the two roots.
Hmm.
So now the question is that from these roots, you have lost the data of the UI, VI, okay, somehow. But you remember the roots.
Hmm.
R1, R2, R1, S1, R2, S2, all these 10 roots. The question is
Okay.
that what is the unbiased test? What is the MLE of, like, how will you find out a good estimator of theta from these roots?
Okay. For each for each pair of u1 v1, suppose ui vi, I have the roots known to me, the
Yes.
values of the.
So a hint is that can you try to find or can you try to get an information about U and V from the roots? Let's say the roots R1, S1 or R and S. What information can you get about U and V from R and S?
From RNS. I can find U and V. If I take the sum of the roots, product of the roots, then I can find U
Do
and
it,
V.
like, do it. Tell me.
So suppose suppose for the first pair I take R1 plus S1 is basically minus 2U, and R2 into R1 into S1 is V squared, and R and S values are known to me. So I will so U is basically then R1 minus R1 plus S1 divided by 2, and V squared V is root over S R1 into S1. So these are the values corresponding to say U1 and V1.
So V cannot be negative.
Mm, no, we can it can it is V is root over R1 S1, so it's plus minus root over R1 S1.
So
It can be negative.
which one you know?
Uh, it can be both positive and negative V. So then maybe I have to take I can take case one, case two. Case one where u ka value is fixed. It is minus R1 plus S1 divided by 2. V is in one case it is plus root over R1 S1. In another case it is minus root over R1 S1.
Okay. But how will you find it in terms of R and S? What is the question boiling down to? Did you understand the question?
Yeah, we have to estimate theta
Yeah. From
from the information given to us.
the roots R and S.
Yes, RNS. From the roots RNS, I can find the exact values of U and V.
You cannot find the exact value of, you can find the exact value of U, but not V.
Not V, yes, because V will again have two cases, so it creates ambiguity. V z
So
plus. So I have the see an unbiased we know that an estimate of theta, say the
essentially
maximum
you
like
have here, if you from R and S, you are getting values of U comma V square, not U comma V.
yes, I'm getting U comma V square.
So can you estimate theta from U comma V square?
U and V are independent. U and V square will also be independent.
Okay.
Yes, they have to be independent. So if I uh, write the joint PDF of U and V squared, for a joint PDF, U we know that it follows normal, but V follows normal. V square may not be normal. So again, we'll have to use a bivariate transformation to find the distribution of V square. No, not bivariate, univariate transformation to find V square. So I have to express this. Suppose I write the likelihood function. It will be f of u into f of v square, product of f of u into f of v square. Then I can go with the usual procedure of taking log and then differentiating. Maybe that is a way of finding theta, finding an estimate of theta. But
Try this problem out.
I'm not using the information given in here.
Which information?
Okay, yes, I'm using the information because theta will be in the form of some ui vi. So I'm getting, say, ui vi square. Then I'm getting that ui vi square from rs information which is given.
Yes.
So maybe this is a way of finding an estimate of theta.
Try to think about it and write the solution down properly.
Mm,
Okay.
mm.
So all the best, and do check out the others interviews, because I hope like we cannot continue the interview for long. I hope it helped.
Okay.
It helped you, and be sure with very definitions, because they can ask you definitions, and be prepared with the past year solutions. Okay, so that they can extend the solutions. They can ask you to do a different variant of this problem, right? Like I have shared to you right now.
Yes, yes. And they can ask me any question from PSB or the ones which I have done.
Any question, they can ask you to extend it, just like I have done.
Yes.
Okay.
Okay.
So all the best, and I hope you enjoyed it. Yeah. So I
Yeah.
will. Yeah. All the best for preparation. Yeah. Bye.
Thank you. Bye.
My pleasure.